Hello, right. Today I want to go over if you're making a brand new Unity project, just some basic code that you'll be able to do a lot with. So, say we're starting from a new project, we'll do a 3D. I'm going to call this tutorial project. I want to just do everything from the start. We're going to make a new folder, tutorial. And just name it something slightly different. Okay, we're going to use this folder, create the project here. So simple as, just so you know, like I'm starting from a clean slate as well. So this is for if you want to build a game in Unity. Some basic like logic on how you'd attach scripts and how to use them, how they actually work. Because it's all very well copy and pasting code and then you run it and it works. But if you understand this basic stuff, then you'll be able to see like, oh, okay, that didn't work how I wanted. Read it and see why it's not working. Because yeah, C# is the language that's used in Unity. You'll also want to get a code editor. So you could literally use like Notepad, but I'll show you the difference. Like if you use Notepad, you could write code in here, it works fine. But then if you have something like this, it gives you nice like highlights. So this is Visual Studio Code. This will like separate stuff out. So you know a string, which is just text, it will, when it's in quotes, it will put it into nice stuff like that. And you can see like a comment. A comment starts with this, the double backslash. That means that code won't run. So this is a comment. That code won't run. So it's a good thing to download and get one that you're comfortable with. Visual Studio Code works so nicely for me. You can also add in extensions here. So stuff that just this one, for example, better comments. If I type in this is a header, then Alt-Shift-X, it'll make it nice like that, right? So it just speeds up your workflow. It's taking its time to build. Yeah, first project. Here we are. So this is Unity. We've got a completely empty scene. What happens when we click play? Yeah, so you see your scene. That is the game. So if we were to create a cube, that will show it just right in the scene, won't it? There we are. Now we have a cube in the scene. So you can right click. This is all your objects in the game. So the cube is an object in the game right there. So you just right click and you've got the options to make stuff. So we could make a sphere. Simple as, right? So, do you know what? I'm going to put that there just so we can see what the scene looks like at the time. So some basic logic. What would be quite fun to do is when the sphere falls down and hits the cube, it destroys the cube. That would be something. So we're going to need to put gravity on this one. That's where to start. Let's make this a bit bigger. So the mesh renderer, this just is the mesh that renders it. That's what it looks like. Collider, what happens when we press play? This has collision on it, but it's got no gravity. So what we could do is add in something called a rigid body. This attaches to the collider. So now when we press play, this should just fall through the scene. There we are. Oh, and this has a collider on it as well. So if we drag it up, it's colliding with that one. So if we took the collider off, it will just fall through. Simple. Simple. Now let's do our first script to register that it's detecting the sphere. Let's do that. So we'll make a new folder. This is our project tab down here. Make a folder. We'll call this scripts. It's going to hold all our scripts in there. We're going to right click, create C# script. This is going to be called detect collision. So when it's in the project folder here, it's doing nothing. It's just written, it exists, but you need to get it into the scene somehow. So we'll drag it onto the cube because we want that to detect it. So we'll drag it onto the object here. And now this is in the game. So if we click here, edit, it's going to open the script in my IDE. This runs when the game starts, right? So a good little function to test it's working, debug.log, capitals matter, and here you could put in data, but we're going to put in just a string saying this script is running. Finish every line with a semicolon here. Save that. It's got to compile. Oh, let's close down my other project. It's my game. Kill Mike. Yeah, save. Okay. Close that one down. So about this. Okay, cool. Now it compiles the script, so it checks for errors and it loads it in. So now there's something called the console here. This will print out any messages that something goes wrong, but this function prints out whatever we put in there into the console. So when the game starts, it will run this. So we press play. This script is running. Cool. So we know that is working. It's in the scene. It's working. So these are functions that are just there by default. You can make your own. So you got to start it with, well, it's good to have it public, means you can access it anywhere, or you could do private. Just for now, just make everything public. It's easier. Then you give it a return type. So void means you're returning no data. But you could, okay, I'll just finish the expression. So we want found object. Let's say that. So when it collides, we want it to run this function. So you name it, you give it how you access it, what it returns, and the name of it. Then this section is for you to pass in data. So you could pass in an int, which is a number. This will be called number. And then you can use that data inside the function. I'll come back to that in a bit. So instead, here we are. We'll copy and paste this in. Tab to indent it. And then we could say has found object. So to call this is just a separate bit of code. This won't run. So we'll get rid of this for now. I just want to go through like what's actually happening so you understand. So now if you look at this, what will happen? We got that code there. Hit play. The script's working, but obviously nothing's happening because we need to call it. So we can run this code by grabbing this. We say when it starts, run this function. So now it's going to print out has found object. Right. It has found an object. Great. But obviously we only want to run that code when it detects some kind of collision. So we don't want that in there. Void update is a good one. This runs every frame. So if we did this in here, what's going to happen is it's going to run that code every frame. Which you want to avoid putting stuff in there if you can, because it gets heavy on the computer. As you can imagine, if you had like 30 different objects all trying to do a lot of logic, that's fine. But you just want to avoid it, right? This might be ugly, but it's working. Let's put that there as well. just so we can see everything. Oh, it's kind of horrible. Okay, so what we want to do on the cube, this one, if we make it a trigger, it doesn't have the collision, so it will still fall through, you see. Let's hit play. It's going to fall through the object. Cool. We don't want to be printing out that. There's something called onTriggerEnter. I'll just copy this code that I've done before. There's no point repeating code. So here, this is a Unity built-in function. It's using these at the start. So these are functions that happen automatically. If you didn't have these in, it wouldn't run these. So private, it's just happening on this object. It's not returning any data. And it's saying onTriggerEnter. It's checking for a collider, which is called other. So that's what we're calling it. We're passing in this data. So this is a trigger. Where are we? Yeah, and so it's checking for a tag. We don't need that. We just want to say if it notices another collider, then we do this. Okay. So this won't work, and I'll explain why. Oh, it did. Okay. It just worked. Just like that. Sometimes you need a rigid body on it. Oh, but the rigid body's on our sphere, so that's fine. It's detecting the collision. So that was simple enough. Now we could have it so it destroys the cube. So it has found it. There's destroy. It's a good little function. So when it finds an object, destroy, game object is talking about this, whatever the script's on is the game object. So destroy is a function that Unity put in. So now it will say it found an object and it will destroy the cube. Boop! Kills it. Simple, simple. Where can we go from here? We could have it so it spawns the sphere when you click. That's something we could do. So how we'd go about that would be quite good. So we want to make something called a prefab. So we don't want in scripts. We'll make a new folder called prefabs. Prefab. And here you can just drag in. So this is the sphere. We'll drag that in here. Well, it's a prefab now. So whenever we make changes to this one, we could drag in a couple of these. Yeah. And whenever we make changes, say we made it like on this scale, we made it like that, it's going to change all of them. So prefab is very handy for when you're using objects like that. Let's just make it a bit smaller just so we can see the changes work. There's no harm in just making these as folders, so we could say spheres. You can just drag them in here, and then when you move this parent object, it will move all of them. That's how that works. But we're going to spawn these in, so we can just delete this. We'll make a new one called managers. Put that at the top. And inside this, we'll have a spawn manager. Manager is just a good word to use. So under scripts, we'll then create a script called spawn manager. Again, that's doing nothing in there. So that's why we make these objects. So we can drag it into the scene. So now this code will run. So edit this script. This is where we're going to go over data. So something called variables. That's a comment there. You say public or private, so declare it. I'll say there's different types. So you've got an int, which is a whole number. So we'd say this was maybe amount, and you finish it with a semicolon. They all default to like 0 or null. So if you said 1, when you save this, it will put it in the inspector, and the amount will be 1. Simple. Let's then just give an example. If you made this private, I'll just make it the same. If I made it private and go back, it's still got that same value, but it's private. You can't see it, right? It's saying we haven't used the variable. That's fine. So what should we do? We need a reference to that prefab we made. So you got int. You've also got public float. If you wanted to do, we'll call this health, let's say. This is where you do 2.1 f. So f is for float. The ints have to be a whole number. So float is a floating decimal point. So it could be 203.1. That's a float. So if you were using health, you'd probably actually go for an int, and this would be more like a cooldown, and this would be health. Because then you don't want 1.5 health really, you want it exact values. So it will round it up and down. You've also got a bool. So this is has spawned, maybe we'll do. And that defaults to false. So it's true or false. And then you spawn the object, and that now becomes true. So you can do checks. If this has happened, do this. If not, do the other thing. And what else is handy to know? You got public string. We could call this the object name, and we call it Steve. And then you can say when you spawn the object, call it Steve. It's got a name. So instead of those variables, we're going to make a game object, and this is going to be called the sphere prefab. So you say how you get it. We'll make it public so we can set it in the inspector. It's going to be of data type game object, and that's what we're calling it. It's a good habit. They call it camel case. We start lowercase, and then every time you reach a new word, make it a capital so it's easy to read. That hurts. Like, it's all one word, but it's easy to read. Easier. So save that. This is why we have a manager, so we can reference data. So in here, now we can go to our prefabs, and we'll drag in our sphere, like that, even though it's not a sphere anymore. So we'll use our void start function, so this will run, and there's something called instantiate. We'll go over what this does. So we'll separate it out because it's good practice. Void, this will be spawn prefab. We're not passing in any data, and we'll run this code. So it's instantiating, basically spawning this object at this position with this rotation. So we want to take in that sphere prefab, so it's going to spawn that game object, and this is referencing the script it's on. So wherever this spawn manager script is, it will put it at that position. You could make that another position if you referenced it, or give it exact values. But instead, let's just do that. So it's going to spawn in our sphere when the game runs at this position. So that's currently in the middle of it. So let's raise it up a bit, like that. Now let's see if this works. Go back to the console so we can see. Play. Oof, it worked. So it spawned it in, and it's still got all those scripts running on it. It's got all these colliders and stuff, which is nice. Okay, we could do it on a key press. So, was it input? Yeah. Probably it doesn't. It moved over to another thing, but in the spawn manager, we use the void update function. So this is being called every frame, which is fine. And it's checking if the input is C. So when the C key is pressed, then we will spawn the prefab. Input, get key down, C, run this code. Cool. Let's try that. And C, it's working. We've got a load of them. You see they got physics on them. It's quite goofy. It's spawning them all here, which is kind of messy. You'd obviously want to clean them up. You don't want them just hanging about in the scene. So you'd say like destroy after X seconds, which I can show. But another way, you could group it as a child. So in the instantiate, it's this extra bit on the end. So it's saying make it a child of this object. So that'll group them nicely up under there. See? So it's making them children of this. Yeah, it's just it's a handy thing. What that also means is anything you change to this object. Say you, oh, I've got to spawn some in, and then try and move this object. Oh, fuck it. But yeah, if you deleted this, obviously they'll all go, right? Because it's a child element. Or you could have them clear up by themselves. You can use something called an invoke. This is quite a handy one. There's better ways of doing this, but Spawn Manager will make a sphere script then. So this is, we'll make a script called cleanup. So you could make a general script and then attach to anything you want to clean up. Edit this one. Public void, and this will be destroy. You don't want to name it the same thing as the class. Leave that code in there. Yeah, and we want to copy that destroy object. So invoke, the way it works, it invokes this function for this time. So we want to get this function, which is destroy, and it's going to do it after 2 seconds. Sorry. It's got to be a float. It can't be an integer. So we could say public float cleanup time, and actually make this 5 seconds. We could do just good practice. And instead of hard coding the value, you give it a variable, so we can just change this, and wherever we use this code, it will all mean that, instead of this being that. When you want to change one, you're going to have to change all of them. So that's the advantage of using a variable. Don't need that in there. Don't actually need that function either. So when the object spawns in, it will start running this after 5 seconds. It's literally that simple. So we'll save that. That's on our prefab, so every object spawned will also have this script. So now they're going to spawn inside the spawn manager. There we are. So we'll spawn a load of them, and you'll see they'll start disappearing because they're being removed from the scene after 5 seconds. Nice and simple. Nice and simple. That's some basic logic to Unity. I just wanted to go at variables, methods. So variables, the data, how you call something, and what it does. We can go over if statements and stuff after. I mean, that's kind of an if statement there. Yeah, let's go over that. So you could say the logic. The way an if statement works, you say if x is equal. Oh no, let's go back. Sorry. if we said x is equal to 1, x means 1, y is equal to 2, if you did x plus x is equal to x plus y, that's how you'd write that. That would equal 3. But you can also shorten that to be plus equals y. That's the same thing you're saying there. You're just shortening it. So that would also equal 3. X is equal to x plus y. Yeah. So that's a variable there. So if we said if x equals y, that doesn't make sense because that would mean x equals 1. You'd say is equal to y. So x is equal to y, that would not run that code because that's not true. That would instead, you say else. This code would run. So if this is true, run this code here if true. Bruh. Else run this code if it's false. So if we then changed y to equal 1, that is true. So this code will run. I hope that makes sense. So you could say if it's saying C, run that. Else debug.log is not spawning. Yeah. So it's pointless code to put in, but I just wanted to show what's happening in the code. You can use a bool, which is true or false. You can set that to anything. If we make this 56, and you say if x is less than or equal to y, then run that. So that would be true because x is less than 56. It will run that code. Right, that's the last thing I'm going to cover. But yeah, I hope you enjoyed this little run over some basic C# stuff. If you want to see more, I'm probably going to be doing some videos on my game, like how I do more complex stuff. But yeah, I enjoyed the idea of making a video. So yeah, hope you enjoyed, and I'll catch you later, guys. Bye.